Alright guys, welcome back to another Gungahlin College Maths Applications video. So this week we're going to do things a little bit differently. So instead of starting off with a video lecture, what I'm going to do instead is give you a video tutorial. So basically all that means is that I'm going to show you a couple examples from the textbook and show you how I would go about solving them. So as hopefully you recall, last week we started a new topic which was arithmetic sequences. So today I'm going to be working from that exercise, exercise 5b in your textbook, on arithmetic sequences. In particular, I'm going to work on, first of all, question 2, part H. So let's just first of all read this together. So the question says, state which of the following are arithmetic sequences by finding the difference between successive terms. For those which are arithmetic, find the next term in the sequence, t4, and consequently find the functional definition for the nth term for the sequence tn. Alright, so what I'm going to do first of all is basically just kind of write out a little game plan over here. So it says basically find out whether or not it's arithmetic, so that's the first goal. Is the sequence arithmetic? Right. Goal 2 is if it is, only if it is, find the next term in the sequence t4. And then part 3 is to find out what tn is equal to. And I want this to be a functional definition. Alright, so that's my game plan. So let's start with part 1. Is it arithmetic? So it says find out whether or not it's arithmetic by finding the difference between successive terms. So I've got this sequence, right? Tn starts with 3/4. The second term is 3/2. The third term is 9/4. And then it keeps going. So to work out whether or not this is arithmetic, so a sequence is arithmetic if the difference between each successive set of successive terms is the same. All right, so if, for instance here, 3/2 minus 3/4 is equal to some constant d, right? And then, so that'll obviously be equal to a constant, but if it's equal to a constant d and 9/4 minus 3/2 is equal to that same constant d. So what I need to do, so if this is true, then tn is arithmetic. So what we need is for this difference here to be equal to that difference there. Okay, so let's see if that's the case or not. So 3/2 minus 3/4. What's this equal to? Well, you can do this in your calculator if you like, but I like doing things like this in my head. So 3/2 is the same thing as 6/4. So all I'm doing is multiplying the top and the bottom by 2, and I want to find something with the same denominator as the second term there, the 3/4. So 3/2 is 6/4, and that was minus 3/4. So that difference, right, is 3/4. So now, in that second condition there, so 9/4 minus 3/2, let's work out what this is. Well, again, I can take 3/2 and again say that that's 6/4, right? So 9/4 minus 6/4. Well, what's that? 9 minus 6 is 3. So that's going to be 3/4. So indeed we found, right? 3/4 is equal to 3/4. Right? So t3 minus t2 was equal to t2 minus t1, and both of those were equal to 3/4, right? So all I'm saying is this number here minus this number here is the same thing as this number here minus this number here, and that difference is always 3/4. Okay, so that answers part 1, that yes, it is arithmetic, or part 1 of our solution. So now we want to know, well, what's T4? Well, so part 2, T4. So another way of saying that the difference is 3/4 is to say that to find the next term, right, in the sequence, every time we add 3/4, right? 3/4 plus 3/4 is 3/2. 3/2 plus 3/4 is 9/4. So to find T4, we'd want to add 3/4 to this 9/4. So T4 should be 9/4 plus 3/4, which is 12/4. Again, you can do this on your calculator if you like, or you can try to do it in your head. So 12/4 is the same thing as 3. So T4 is just equal to 3. And that's it. So now we can move on to the next part, which was to try to find a functional definition. Definition for Tn. Okay, now remember, in last week's classes, we said that when we have an arithmetic sequence, it's always going to have a formula that looks like this. Tn is equal to a plus n minus 1 times d, right? Where this is the first term in your sequence, and this is the common difference. Well, we've just found, right, that d is equal to 3/4, and we can just go back. So where did our sequence start? Well, it started with our first term was 3/4. So we also know a is equal to 3/4. So we can write out now, basically just plug these numbers into here. Tn is equal to a is 3/4 plus n minus 1 times d, which was also 3/4. We can actually simplify this down a little bit. So this is 3/4 plus, we're going to multiply everything in that bracket by 3/4, so that's 3/4 n, minus 1 times 3/4 is minus 3/4. 3/4 minus 3/4 is 0, so this whole thing is just 3/4 n. So that's it. That's the full solution to that question. So this was Tn. Okay, so now I want to move on to something slightly trickier, which is question 11 from that same set of exercises. So this question says, if T10, so the 10th term in the sequence, is 100, and T15 is 175, find the first term, the common difference. So the first term is T1, or that's the same thing as A, right? And then we want to find D, and then we want to find the nth term. Okay, so let's think about this. So it's arithmetic, right? We're told that, the arithmetic sequence. So it's arithmetic, so we know that it's going to follow this equation, right? Tn is going to be equal to a plus n minus 1 times d. So if we plug in this 10th term, right, so when n is equal to 10, that means T10 is equal to a plus 10 minus 1, right, n is 10, times d, which we don't yet know. So this is a plus 9d, and we also know that this whole thing is equal to 100. Right, so we have a plus 9d is equal to 100. Now we were also told about t15, so when n is equal to 15, t15 is equal to a plus 15 minus 1 times d. Right, we can simplify that. 15 minus 1 is 14, so that's just a plus 14d. And again, we know that this is equal to 175. Right, that's that bit of information there. So writing this all in one line, a plus 14d equals 175. Alright, so now we have a plus 14d is equal to 175, and also a plus 9d equals 100. So this should be looking really familiar because just a couple weeks ago we talked about systems of equations. So a plus 14d is 175, a plus 9d is 100, so that's two equations and two unknowns. Right, so that's a system of equations that hopefully we can solve. So there are a number of different ways of doing this, right? We just learned how to solve this whole thing with matrices. So what I'm going to do is instead of using matrices, go back and do it the way that hopefully you guys would have learned to do it in high school. So I'm going to label these equations first of all. This one's 1, and this one's 2, and then I'm also going to highlight them. So this is 1, and this is 2. So what I want to do is eliminate one of the variables between these two equations. So I can actually take equation 1, right, and say subtract equation 2 from it. And that would hopefully eliminate a, right? So let's try to do that. I'm going to take a plus 14d is equal to 175, and I'm going to now subtract the equation a plus 9d is equal to 100. So I should put brackets around this. So a minus a is 0. 14d minus 9d is 5d. And 175 minus 100 is 75. So that gives us a nice little equation that we can solve now, right? So I can divide both sides by 5 to give me d is equal to 75 divided by 5, which is 15. Alright, so now I know d is equal to 15, so now I can plug this in to one of those equations to work out what a is. So let's do equation 2. So we have now remember a plus 9d was equal to 100. We just found that d is equal to 15, so this becomes a plus 9 times 15 is equal to 100. Right, we can simplify this. 9 times 15 is 135 is equal to 100. So now I can subtract 135 from both sides and get a is equal to negative 35. So now we know d and we know a, so we can plug them into that equation. Tn is equal to a plus n minus 1d. And find that equation Tn. So Tn, a is negative 35 plus n minus 1 times d was 15. So again, we can simplify this by multiplying everything in the brackets by 15. So this is negative 35 plus 15n minus 15. We can combine like terms. Negative 35 minus 15 is negative 50, and 15n is 15n. So I'm going to write this as 15n minus 50, and that was our equation for Tn. Okay. Now, if you're happy with that, that's fine. But I'm actually going to show you a little bit of a shortcut way of doing the same thing. So I'm actually going to go back here and label this. This is solution 1, but I'm going to show you a different way of doing it. That's, I think, a little bit easier. Okay, so I'm going to call this solution 2. So we just said that we have this sequence, right? It has T10, which we know is 100, T11, T12, T13, T14, T15. And again, we know this guy right here is 175. Right, so let's think about this. We know that each one of these differences is d. So what I want to think about is how many copies of those d's do we have between T15 and T10? Well, we have 1, 2, 3, 4, 5, right? So 5 d's, 5 copies of d makes up 175. 175 minus 100, right? This total difference. So that's 5d is equal to 75. And now I can divide both sides by 5 to give me d is equal to 15. Okay, so now we know d is equal to 15. And from there we can basically do exactly what we did before, right? We can say, well, okay, I know that, for instance, T10 is equal to a plus 10 minus 1 times d. And this is a plus 9, right? And we just said d is 15, so that's 9 times 15. And that this whole thing is equal to 100, right? So this is a plus 135 equals 100, and I can subtract both sides. So this is exactly what we did before, right? To give me a is equal to negative 35, right? So I'm not going to go through the rest of it, but you can see that you can now write out what Tn is, exactly as we did before. Okay, so basically all I wanted to do was show you another way of doing it, right? So if this makes sense to you, it might be a little bit shorter, but it's probably also easier to make a mistake with. On the other hand, this one's harder and takes longer, but it's probably harder to make a mistake in doing as well. Okay, that's all for now.